All right, everybody, how are you feeling? Great. Peace. Thank you so much for coming. Yeah, it's always the big joy, the big spotlight of the month for me to share this night with all of you. And yeah, let's give a big shout out to Sentry and Kat this woman. Yeah. Yeah, I really like this. I like Sentry, their team, how they take care of us. You can feel that, they really make us feel super good. So thanks for that. I will share something I tried at doing at Sentry for the first time as a. So did you know that? So I think what Sentry is doing really well, it's how they integrate with frameworks. And they recently built an integration with Yabida, which is a Rails observability tool framework built by evil Martians. And it's one of the few open source projects that is built by us and used by 37 Signals. So we take pride in that. And Sentry recently built Sentry Yabida integration, which means if you use Yabida for your Sentry or for your Rails project, for your Rails application, you can build something like this. So these charts are not showing much because I just published. I just pushed merge an hour ago, I guess, on one of our internal tools. But yeah, you can build the whole kind of dashboards with lots of different metrics, sort of like Grafana. I never used that before, but yeah, also experimented with some LLM observability metrics, all of that. So yeah, big shout out to Sentry for building this integration. This was like super easy to set up all of that. And my other announcement is, of course, this. By the way, yay! So, guys, those of you who don't know me, actually, I'm noticing some new faces. My name is Irina. I run Evil Martians, which is a software consulting company working with startups, and I organize this meetup. And once a year, actually. Last year was the first year, so maybe once a year. So we host a conference, which last year gathered around 400 people. So it's a large event that we host, and this year it's going to be on November 10th to 12th. And by the way, 12th is a community day, which means we'll be collaborating with all of you to create different community events, which is super cool. But this year, we already sold out the early bird tickets, but the general admission tickets are now on sale. And importantly, we also have the CFP. So if you want to propose a talk, please propose it. It's open till July 27th. And we already confirmed a few speakers. One of them is this guy. So it's the president of Y Combinator, Garnet.js, who's a Rubyist. And this is, I hope you can see our purpose here. Our goal is obviously to make all people and all founders and all companies that are not building with Rails jealous. So like I say, our metric is the FOMO of everybody who's not building with Rails. Yeah, so go check this out. Also, on this sfruby.com, we have Ruby jobs. I'm updating this website about once a week. And we have amazing jobs. We already know people found great jobs. For example, folks from Apple told me they hired somebody. And yeah, literally, I was on Fillmore Street and Catherine from Apple ran to me and said, "We hired somebody through sfruby." Yeah, so it was almost like that. Yeah, and I also know other people found jobs, and again, these are jobs from great companies also by applying, you support this meetup and you support companies because you think that it's easy to hire. It's actually incredibly hard to hire a Rails engineer right now. So if you're looking for a job, please take a look, click around. You have different filters and stuff. And we have a newsfeed. And I was just at RubyConf, and Mats showed an RSS reader. And of course, I added an RSS to this newsfeed. Yeah, the way it works is, obviously my agents are collecting news from different Rails companies. So these are more business-focused news. But it's interesting to take a look to understand, all the new big deals, different things, etc. So take a look, sign up to the RSS. And we'll have 3 amazing talks tonight. We'll have Cameron, Alex, and Marco. We're doing a little replay of RubyConf in a way, with somebody is doing a director's cut. We'll see. And then after those talks, we'll have a break. And after the break, we're going to do my new favorite part. Are you already tired of it? I don't know. So we're doing everybody's introductions. So everybody, I'm sorry, every single person whom I can make eye contact with will come here for 1 minute and introduce yourself. Just introduce, and then it's going to be much easier for us to connect, and you'll have so you can think about your introductions already. And yep, that's what we're going to do. And I invite Cameron, and yeah. All right. So guys, you remember Cameron is also our co-host at SF Ruby. So if you submitted a talk proposal to the meetup and got no response, that's Cameron. I'm sorry.
Because I really just hate everybody here, so that's why.
No, seriously, submit talks. So we have a link in every meetup description. Submit your talk for this meetup as well. Okay. Cameron, how many? Cameron loves experiments, I think. So yeah, that's one of them. I think it's fine.
It's working. Okay, awesome. Well, hey, thanks everyone for being here. This is, just a recap of the talk that I gave at RubyConf a couple weeks ago, or I guess last week. Time flies. You may notice a couple of cat hairs on my shirt, and that's because this happened today. This is my cat, Polly. She doesn't usually do this, but she, I guess, was feeling sad that we locked her out of the outside world today. But yeah, I'm Cameron Dutro. I work at Cisco Meraki. There's my social media links there. And today, I'm going to tell you a little bit of a story. So the story begins at RubyConf in 2023. This is the first conference that I attended after the COVID lockdown. It's in San Diego. And on day 1, I walk into the event venue and there's just nobody around. There was not anybody milling around talking. The place was empty. And I was like, what is going on? Did I just forget how conferences work, right? And that's because day 1 was the hack day, which is the first thing or the first time they'd ever done that. And so I just ended up wandering back into one of the rooms that did have people in it, sort of off to the side, a bunch of people sitting around tables. And I just happened to sit next to Kevin Newton. I didn't know who he was at the time, but I later found out through conversation with him that he was working on the Prism parser, which is a new parser for Ruby that he'd been working on for a bit at that point. And I just sort of randomly just said to him, hey, do you think you could write would it be possible to write a Ruby interpreter for the browser, using Prism's WASM bindings? And there was a photographer there who ended up capturing this moment. I didn't think to take a picture. I didn't know sort of how pivotal this moment would be for me, at least in Garnet's future. But there was a photographer, and I was searching for photos, and I found this, and that's definitely him and I sitting there working on this, because Kevin just like whipped out his laptop and started writing this, and I was obviously not paying attention. I was talking to Ufuk and didn't even know what was happening, but he was like as fast as I've ever seen anybody code, like almost LLM speed. He was like coding this really simple Ruby interpreter. So that was super, super fun and interesting. And at the end of that process, I had a little snippet of code that sort of became Garnet. So I'm going to say Garnet was sort of officially born on November 13th of 2023. All that it could really do was just add two numbers, specifically 1 plus 2. But that actually did work, and it used Prism to do it. And if you're interested in looking at that code, I ended up digging up the gist as well that he posted on his gists, and click on that, you'll see the old code that we wrote back in the day. Just I think 60 lines or so. Okay, so let's talk about a little bit of a history before we dive into Garnet itself. So previously, this is sort of way back in the day when I first started using Ruby. Actually, first show of hands, who started using Ruby in the 1.8 days or maybe earlier? Yeah, for sure. Me too. We actually used Ruby Enterprise Edition. But this thing uses a classic AST-based interpreter, and AST is an abstract syntax tree. What that means is it's a series of nodes in a graph that you can walk in order to understand how the program executes. So what the interpreter would do is it would parse source code into these ASTs. Then it would walk the tree structure and do the actual operations like plus or whatever right there in memory, and then the result would be just the end of that. That process would be a result, an object of some kind. But that's not how Ruby works today. So in 2005, Koichi Sasada started working on YARV, which is, and it was merged into Ruby 1.9 in 2007. And this stands for yet another Ruby VM. And what it did was it replaced this abstract syntax tree walking technique with something called a virtual machine, specifically YARV virtual machine. And what happens instead of AST walking now is that the AST is still walked, but instead of actually performing all of the math and the operations in memory, it emits a list of instructions. And these instructions are called bytecode. And then those instructions are interpreted by the VM. This is also how the JVM works, how Java works. Java compiles to bytecode. Then anywhere that you can run the Java virtual machine, you can run that compiled Java code. And the idea was to compile once and run everywhere. I should also mention that one of the big reasons that Koichi worked on this is because it ended up boosting the performance on average of Ruby by about 4 times, just that one introduction of that virtual machine. Well, so what is a virtual machine? Well, I found this like sort of helpful definition on Wikipedia. What it's saying here is that a virtual machine just provides a layer of abstraction, usually a layer of abstraction over hardware. And that's kind of what's happening here. Ruby itself translates your code into machine instructions that run on the actual CPU, but you write Ruby, or more appropriate or more correctly, you write Ruby that becomes YARV instructions. And then those things run on that VM, which translates those instructions to actual machine instructions. So why would we want to do this? like why is there a performance benefit? Why would you want to do this? Well, obviously the big one is performance. And the reason for that is because there's sort of multiple reasons here. So for one thing, like instructions in bytecode, or rather the virtual machine instructions, like when you write the code that handles an instruction, it's simpler to write, to maintain, to understand than an AST would be. It's also simpler to execute, so you're not dealing with a bunch of in-memory pointers to things. And actually that leads into better memory locality. You're not chasing pointers through memory to find values and whatnot. You're simply executing those instructions. The next one on the stack, the next one, sorry, not on the stack, the next one in the list. Easier to optimize. So AST-based interpreters are not super good at like dead code elimination and whatnot. It's a little easier to do with an instruction list. Easier to instrument, so you can attach breakpoints more easily than an AST. So what exactly is YARV? So it compiles your AST into instructions. Right now there are 107 or so, I think. There's more. I just saw a an issue filed against Ruby to make a new one. So there's more coming. And then it uses a simple stack instead of the heap for keeping track of objects. And then what the instructions do is they just push objects onto the stack and pop them off. Here's an example of how this might work. So here's our abstract syntax tree. We're just assigning foo, the local variable, equal to the operation 1 plus 2. And this is how Prism, I think my names are a little off here, but the idea is the same. At the very root of this tree, we have a local write node. And then we have the identifier, which is foo, and then the call node, because in Ruby, everything's a method call, right? So we're saying 1 is the receiver. We're calling dot plus, the plus method on 1, and passing in the argument 2. So we'll start, we emit instructions for this AST. We start at the root here. We go to all the way down to the call node, look at the call node's receiver and its arguments, and we visit the receiver first. And we generate what's called a put object instruction, and put object just says push 1 onto the stack. Then we visit the arguments, so we push 2 onto the stack. Then we emit our plus instruction, in this case opt plus, which is an optimized plus for things like numbers and strings. Otherwise, this would just be a send. And then the last thing we do is, or second to last thing we do is do a set local. So we're saying assign the foo variable in the locals table, which is at index 0 in the locals table. Assign that equal to the result of this operation. And then finally, we're done, and we emit a leave instruction, which just means I'm done with this particular scope. Let's look at how we might interpret these instructions now that we've generated them. So we start at the beginning. We encounter a put object instruction at position 0 in our bytecode list. And what that does is just pushes a 1 onto the stack. Next thing we do, push a 2 onto the stack. Now, this is kind of where the magic happens. We encounter our opt plus instruction. This pops the argument off, then it pops the receiver, which is the 1. Then it adds them together, calling that plus method on integer, and then pushes the result onto the stack. So now when you're finished, and then there's set local, which of course assigns that value to the local variable foo, and leave, and we're done. The return value of that 1 plus 2 was sort of just left on the top of the stack to be assigned to 2. Okay, so Ruby has a couple of tools that help us dump an abstract syntax tree and to dump the instructions that a particular chunk of Ruby code will evaluate to. And we can see this really easily by just passing this dump instruction to the Ruby executable. So dump equals parse tree, and then I'm saying -e, which says take this snippet of code. You can also give it a file, but I'm just giving it a little tiny snippet of code to make this more digestible. And what this will do is print out the Prism parse tree or the Prism AST that got built from that snippet of Ruby code. You can also dump bytecode instructions. So we'll take the same example, 1 plus 2, and we'll say dump equals INSNS this time. And you can see that even though this might be a little bit hard to read, the same basic building blocks are there. We're just put object 1, put object 2, opt plus, and leave. And I left out the local assigns here for simplicity. Okay, so before we, I keep saying before we talk about Garnet, a lot of front loading here. Let's write a simple YARV compiler that hopefully will illustrate these concepts with code. So the first thing we need to do is define our instructions. And this is what I said before. The instructions themselves are actually pretty easy to understand and pretty simple. So we have our put object class. This thing just takes in an object that it's going to push. That object has to be sort of knowable ahead of time. In this case, that's the 1 and the 2 we talked about. That's the object there. And then when the instruction actually gets invoked, it's going to do some work. All that it's going to do is push the object onto our stack. And the stack is just an array. There's also, as you may have seen in the previous slides, there's a special optimized instruction for the number 1. There's also a special instruction for the number 0, because those appear in Ruby code a lot. And so rather than taking up stack space, or rather than taking up instruction space for like the opcode and the operand, we can just literally emit a 1 with the item, in this case, put object into fix 1, and this just pushes a 1 onto the stack. And so again, this is even simpler than the last instruction. All we have to do is say push. And actually, I should have changed this to, I think I copied this from JavaScript. So push works. You can also just do the shovel operator. Here's our plus instruction. So this thing takes in some call data. This is not important to understand what call data is. We saw that also on the previous slide. It just includes things like what the method ID is and how many arguments it's called with. In the case of plus, it's just 1 argument, and we always know the method name as well. But all that this does is it pops off the argument, it pops off the receiver, it calls plus on the 2 things together, and then pushes the result onto the stack. So again, like pretty straightforward, I would say, in terms of like actual logic happening. So finally, we'll compile our instructions, and this is currently not doing anything. I'm just showing the setup here. So first we parse our abstract syntax tree with Prism, and then we call our compiler's compile method, give it the AST, and we expect an array of instructions out the other end. So filling this out a little bit more, because we want our compiler to be kind of stateless here, we'll just make a new one, visit, and then return the instructions array so that you don't have to know how to do that as a caller. And then we can do what's called add some visitor methods. So Prism comes with a visitor. It's an implementation of the visitor pattern, which is a gang of 4 pattern. And what this will do is when you call visit, we'll go back one slide here. When you call visit on the compiler, that will walk all of the nodes in the abstract syntax tree and invoke methods on your visitor that correspond to each type of node in the tree. So in this case, because we have 1 plus 2, we have 2 integers at play here, we need to be able to emit instructions for pushing those onto the stack. So we just define our visit integer node method, which the visitor, again, automatically calls for us. This thing receives the integer node itself, and we check to see if the value is 1, and if it is, on we add to our instruction list the special 1 instruction, put object 1. Otherwise, just regular put object. So this handles both cases, the 1 and the 2 for our receiver and our arguments. And the last thing we have to do, really the most complicated thing remaining, is handling the call node. So you may remember that it was called opt plus. That's the instruction that we want to emit here. But all method calls are just call nodes in Prism parlance. And so we define our visit call method. And then all we have to do, because we defined our visit integer method before, we now can just call visit on receiver and arguments. And this will implicitly cause them to be visited, which will generate this put object instructions we talked about. Then we just need to make a call data object. Again, not super important what that's doing. Check to see if a plus method is being called. And if it is, we can generate opt plus, add that to our instructions array. And then, of course, I'm leaving it up as an exercise to the viewer to do that for other methods, or other types of methods. So not just plus. So yeah, that's all that we have to do. And then at the end, because now we have our list of instructions, we loop over those instructions. We just pass this reference to the stack, and what those instructions do is push and pop values. And at the end, what we have at the end here, we pop the last value off, we puts that, and it should print out 3. In fact, it does print out 3. This is all the code. Don't read all this code, but this is all available on GitHub here. There's also just a regular like AST walking example, so you can compare and contrast the two. But yeah, all the code's there. Okay, so now we're finally to the Garnet. Okay, so what is Garnet? Garnet is an implementation of all that we just talked about, the YARV virtual machine in TypeScript. And why we want to do this? Well, because we want to interpret Ruby code in JavaScript environments, potentially. So that would include Node and the browser. And what I'm trying to do is mimic MRI exactly, so we're going to bug for bug. And of course, that's an incredibly ambitious project. Ask Charles Nutter how he thinks about that. And right now, the project really just exists for my own and maybe the implementer's own edification. Like, it's not supposed to be a fully working Ruby, at least not yet. It's really for education purposes at this time. Okay, let's look at some of the internals of it. So as I mentioned, it uses Kevin Newton's Prism parser to compile to WASM, and then we load that inside a node process, for example, and we can ask it to parse Ruby code, and it gives us back a syntax tree, and there are JavaScript bindings for that, which make that really easy. It uses the Onigmo regex engine, also compiled to WASM. So this is the C project that is actually separate from MRI that we can compile to WASM and then use. So now we have regexes essentially for free in Garnet. We have to write our own regex engine, which would also be a lot of work. And emits YARV instructions just like MRI does. And then it executes those by looping over them, as we saw in our. Okay. Oh, and it's stack-based, of course. Okay, so how complete is it? What can it currently do? Well, so as of a couple months ago, it could run the entire Flex test suite, but then the Flex people changed their test runner, so I have no idea if it works now. And it does pass a good number of Ruby spec tests. Ruby spec is the giant set of tests that all Ruby implementations, for the most part, test against. So we've got, I don't know how many are actually passing because Garnet does not correctly print out that answer at the bottom, but it passes a number of them. And a lot of good and important language features are currently implemented. So arguments, which you may not think as being difficult, but arguments in Ruby are super complicated. It seems to handle those, I would say, mostly correctly. It also, actually, Miles is going to laugh at me because there are lots of subtleties to blocks, procs, and lambdas that he and I have just been realizing Garnet does not fully support. So, but those are mostly implemented as well. And then it also implements enumerables, including the yielder, which I had to use promises for. Come talk to me if you want to learn how that works. That's kind of a while. The standard library, so all of Ruby's many bits of the standard library are also still a work in progress. If you want to help, you can always come and take a look at the issues that we have filed against the project in GitHub, and lots of good starter issues there. And this was just for the conference, but so this doesn't apply to all of you, but we also had a booth at the Hack Day for a little bit more on the internals, and I have a sort of a side-by-side with how MRI works. But because like one of the sort of biggest problems with writing an interpreter in a typed language is that you need to be able to refer to these objects in some generic way, and that's what R value is. So this is very similar to Ruby objects in C Ruby, where they would be called values. In Garnet, they're called R values. On the stack, there are R value pointers, so we can share references to objects. There's a couple of global objects, Q-nil, Q-false, and Q-true. These are just the singleton instances of these classes that you would expect in Ruby, like true class and false class. And then the last three items here are sort of designed to help people contribute more quickly. These are sort of methods that you might call at the beginning of a standard library function. They're pretty common. So we're just going to say like args.scan is like, how can I take the positional arguments array I've been given and try to pull certain parts of it out, so required and optional arguments. We want to check to see if an object is frozen before you mutate it. Then we also want to make sure that we got past the correct objects of the right type. Those are all the last three there, sort of a helpful like primer on how you might write a standard library function, should you choose to do that at the Hack Day, for instance. R values, so in Ruby, everything's an object, right? And this is a pretty simple concept, but it turns out to be kind of the backbone of everything in Garnet. In Garnet, every Ruby object is R value. And all that really an R value is just a wrapper around JavaScript objects. So we have, in this case, we're showing that we're making a new instance of the object class. And so you make a new R value, we give it the class that it's supposed to be, which in this case is object class, and then just some empty object. So this is similar to the typed data concept in MRI Ruby. We're just associating a class with some JavaScript data that we can manipulate later. So now we are armed with all that knowledge. Let's implement in Garnet hash fetch. And if you're not familiar, or maybe have forgotten how hash fetch works, some subtlety here. So hash fetch sort of in the, let's say, success case, if you have a hash and you call fetch on it and you pass a key that exists in that hash, it gives you back the value. If you try to fetch a key that doesn't exist, it will raise a key error. If you pass a key that doesn't exist and provide a default value, it will return that default value when the key doesn't exist. If you, instead of passing a default value, pass a default block, it will evaluate that block when the key doesn't exist and return the value of the block. Okay, so that's sort of the entirety of hash fetch. So yeah, let's try implementing this in Garnet as a way of sort of like, trial by fire, like example of how this might work. Okay, so the first thing we have to do is define the hash class, and we can do that by saying define class. It takes a base class, in this case object class, and then it also takes a callback method here, which it will call with this instance of that class, or sorry, the class object you can define methods on. So in this case, we're defining fetch. This also takes a body method or a body function. And then the first thing we do is just grab this hash data structure. So there's a hash data structure in Garnet that's designed to just be a wrapper around a JavaScript map, essentially. So grab that out, then we scan arguments. We wanted to grab one required argument and one optional. So the required one, of course, would be the key to fetch, and then the optional argument is the default value. Assign those to variables here in JavaScript as well. Okay, and then it's pretty straightforward from here. We just say, okay, well, if the hash has this key, then we'll just return it, return the value out of the hash. if the return didn't happen, we fall through to this case that if there's a block, then we invoke that block. A block is just a proc. So we're saying this, we're doing this get data thing again, which just has this is the way you would get the JavaScript data out of a Ruby object. So we're getting a proc out of it, and then we're calling it, passing in the key that we want to fetch. Okay, so if there was no block, but we have a default value instead, then we just return the default value. Otherwise, we throw our key error and an inspected version of the key that was not in the hash. So that's the whole thing. Now, that might be a little bit intimidating, but there's not really that much going on here. There's just some setup. We're pulling data out, pulling arguments out. Then we're just running the algorithm. Like, does it have a key? Otherwise, go default. Okay, that was a lot. I totally recognize that. So for the last part of the talk, I want to get a little more fun. Who has seen Drew Bragg's Ruby Game Show in the past? Okay. Oh, a lot of people haven't. Okay, this is good. So Drew Bragg, the guy with the shiny shirt, runs this game show where he will sort of throw up sort of this random and very weird looking syntax that's valid Ruby syntax, and he has a couple of contestants, usually a senior and a junior person, and they're supposed to determine like what his code snippet prints or evaluates to. And a lot of the answers are super surprising if you haven't seen the syntax, and even if you have, it can be really confusing. There was actually a time, I think at RailsConf, where he gave this presentation and Mats was sitting in the front. So there was a question that even Mats didn't know the answer to. The thing, though, that I found when I was watching these back and also in person was that I was able to answer a lot of these questions because I've been working on Garnet and because I had more deep knowledge of how Ruby works. And so I thought I would describe some of that today, and we can hopefully have some fun with it. So a little audience participation. Okay, so what is the output of this code? Give you all some time to digest it. Okay. Raise your hand if you think the answer is A, argument error. All right, for that one. B, nope, string nope. Okay, some hands. The string okay. Okay, a lot more hands. Last, a syntax error. Okay, we got some hands for syntax. Okay, it sounds like C was the consensus. Answer is actually B, nope. Okay, what is going on here? Well, this essentially just evaluates to this, right? So what is empty parentheses doing? We dump the parse tree for this using the tools we learned from the talk here. We can see that Prism actually gives us back a parentheses node. Specifically, a parentheses node with a nil body in it. Okay, so that's interesting. What does that mean? Well, what this means in instructions, at least, is that so put self would be the object this is the receiver of puts. In this case, it's just main, right? And then the argument to puts is what this second instruction is doing. That argument is nil, and we're calling puts after that on the receiver and the arguments. So what this ends up doing is evaluating to nil, right, which ends up printing nope. This is how the compiler handles this in Garnet. So it says if the body exists, then we visit that body, which of course would be some expression. Otherwise, we just put a nil, and that's where that put nil instruction comes from. Okay. Next question. What is the output of this code? Raise your hand if the answer is A, name error. One thinks name error, okay. B, system stack error. Infinite recursion. Oh. Okay, nil. Okay, that seems to be the consensus so far. Or no method error. Okay, I think we all are dialed in on C, that's correct. All right, but why does that happen? So if we evaluate px, we just print out x without defining it first, this results in an error. So because there's no local variable x or method. But if we assign x to itself first and print it out, and we get a nil. So why does this happen? Well, let's look at the parse tree again for px. You can see what's happening here. There's two method calls, right? There's the call node, or the call node for p, and there's the call node for x. But x is not supposed to be a method, right? So you can see the name here is x. We can also see that the locals table for this code is empty. There's no local variables in here. If we print out the instructions, we can see the same thing. We're calling x, and then we're calling p. But that's probably not what we intended to do, right? Because there's no method x. If we instead assign x to itself, we can see what happens is now, instead of two call nodes, there's a local variable write node, which we saw before, and there is a local in the locals table. Okay, this is because Ruby realizes, or I should say, I guess, discovers local variables if they are assigned in the body of the method. And that's the only way that it knows that a variable is not a method, because it was assigned in the body of the method. And so that's how it knows the locals table. That's how it sets that up. And what it also does whenever the method is invoked is before it actually invokes the method, it assigns every local variable to nil. And I should say here's the instructions set. We can see there is a local in here, x at index 0. And we do a get local here. Okay, in Garnet, the way this is done is we grab the locals out of Prism. Prism has already gotten those for us. We have a local table that's populated with all those values. And then we iterate over them. And for every local, we make a new R value pointer. And then execute the frame. Okay, our last question. This one is a doozy. Okay, so what is the output of this code? I say a doozy because there's lots more syntax. Okay, is the answer A, syntax error? All right, sorry, I'll go back. Raise your hand for syntax error. Okay, 3 or so. That B, the string proc. Okay. That was a lot more hands. Is it argument error? Hands for argument error. Or, oh, one over there. Okay. I think Andre just had an epiphany. All right. Or is it D, the hash hello proc? Okay, got a few people for that. Okay, it actually is D. S. Okay, why does this happen? There's a lot going on in here. So the first thing to realize is that proc is not actually a keyword. Proc is just a method on kernel. And so if we redefine proc using the same knowledge we learned before, that turns it into a local variable. So we're sort of shadowing that proc method. Okay, if we dump the instructions for this, we can also see that's certainly true because we're doing a set local and a get local here, both to a variable named proc. There's also a lot of different ways to call a proc. So you can call proc.call, but you can also call it with dot parentheses, dot square brackets, or with just straight up square brackets. You can see right here, we can also see that happening here. Opt aref just means array reference, I think, or array access. It's essentially just the method call of square brackets on whatever is on the top of the stack, which in this case is our proc. Okay, the last thing is that proc args are not strict. This is why we don't get an argument error. So if we use a lambda instead, and we call that lambda without an argument, we get the expected argument error. We didn't pass enough arguments. But if we have a proc instead and we call that without arguments, that works just fine. Okay, so that explains sort of all of why this doesn't work, or all of what this does, right? So we're assigning the value of proc equal to a proc, which returns a hash. And then we're printing out the result of calling that proc with the symbol hello, which we just ignore. Okay. Okay. In Garnet, this is how that's handled. So a block is, or proc is really just a block, or a block is a proc rather. Just return the block, which is itself an instance of proc. And then in the setup arguments method, which is where all the arguments handling happens. The slide is wrong, by the way, don't look at it too hard. We check to see if the calling convention, so if this thing is a method or a lambda, and if it is, then we check the arguments, and if it's not, we don't check that. Okay, that's the end of the fun. Garnet needs your help. We have lots of starter issues on GitHub. You can submit a pull request. Don't ignore the hack day thing. That's for the conference. It'll be super fun. Here is a QR code. You can check out Garnet, a full working version of it in your browser, garnet.js.dev. And yeah, thanks a lot. That's it.
You have questions? Let me know.
Ciao. I was just curious how the hack day went. Did you get a lot of submissions and make a lot of progress?
We had 3 people come, yeah, and each of them submitted a PR. It worked pretty well, I guess. I mean, it was more than I expected. Sorry, there we go.
I suddenly speaking like with a turtle voice.
Sorry, gentle voice. Turn it back.
Maybe we had another one.
I was wondering if you had more fun on the Ruby side or on the browser, WebAssembly, JavaScript side.
Oh man, I think I had, well, specifically when it comes to WebAssembly, I had more fun with that. Like, I learned a lot about compiling, like, so Enigma specifically, which is that regular expression engine that Ruby uses, that, like I mentioned, is a separate project and written in C. I'm not really much of a C programmer or much of a C toolchain person. And by the way, without the use of LLMs at all, I was able to figure out how to compile that into a WASM module and then call it from JavaScript, which required a lot of research, a lot of messing around. But when it finally worked, it was like so rewarding. So that's why Garnet is able to like do all the regular expression stuff that it does, because it's able to call into that. That was a super interesting project. Yeah.
Did you benchmark? Did you test if there are any, like how it performs?
Oh, it's terrible. But again, that's not the point. I benchmarked. I can't remember what it was. I benchmarked one thing and it was much slower than MRI, but that's kind of to be expected, right? It's not supposed to be fast. It's supposed to be for learning.
What would one do with this?
Learn how interpreters work.
Cameron, thank you. Doing all this research into Ruby and its internals, has this changed your style, your personal style at all in writing
wow.
Ruby?
Oh, that's a really interesting question. I think it's probably given me like more, it's made me want to do more with less, I suppose, because like when a super short Ruby program can compile to like lots of instructions, right? And so you don't always know if it's going to generate lots of instructions, and that could be slow because generally more instructions is slower than less. And so I guess in some like, I guess in some ways what I'm thinking when I write Ruby now is like, will this be slow because of the instructions that it emits, you know? And the answer is usually no, but there have been times where I've dumped the instructions and been like, oh, well, it's probably slow because it has to, you know, invalidate this cache or whatever. And speaking of that, Garnet doesn't do any caching at all. And so I have less experience with that side of it, but that's certainly been in my mind, right, as I'm writing Ruby.
Just, I'll go first. Cameron, so imagine this group, if you lock us up here, how much time, in how much time can we finish the full MRI implementation as this group?
I think that if you were to give Garnet to Claude or something, you could probably finish it in a couple of days. But that, again, is not the point of the project. The point of the project is to learn. And so I cannot imagine it ever being finished, honestly. I mean, is JRuby finished? I don't know, maybe. Hard to imagine it ever being truly finished.
In your test suite, are you collecting a good corpus of absolutely cursed Ruby to haunt people's dreams with, or?
Yeah, to give back to Drew Bragg. Here's the, no, actually, I'm not. I mean, the project is challenging enough that like I just trying to get the basic things to work. You know, it's the cursed things. If they show like when I was first working on this and trying to get the Flex test suite to pass, that was really the North Star. Like, can I get all of the Flex tests to pass? And so whatever Flex needed was what I implemented, right? And it's now different than that because now though it's tested against Ruby spec, but I have to, again, there's like, I would say so much to do that I've just been able to pick the easier things up until, I mean, I think probably for the foreseeable future. So the cursed parts I'm sure are coming later, but I have not personally dealt with those yet.
Did you try implementing the Flex compiler? Or did you run into that?
The Flex compiler did not exist when I was writing my tests for it. But that would be super cool if we could get that to work. Yeah.
All right. Thank you, Cameron.
Thank you.
Yeah, join the project to now to learn Ruby, really, right? We should all. David Thomas's talk, right, says start writing Ruby, like that. Right. So this is a very special talk for me because, as you guys know, there are only two of us in San Francisco from Evil Martians, me and Victoria. And whenever our colleagues visit, it's always very special. So Alexander is visiting from Lisbon, from Portugal. He was also speaking at RubyConf. And yeah, so I hope you enjoy this talk because it's great, like background jobs wisdom. And I think it's based on it's based on a lot of work we're doing at Evil Martians.
Hello everybody. I'm Alex. I'm a backend engineer at Evil Martians. Yes, and today I'm going to talk about how to be fair to your users. More specifically, how to provide consistent quality of service across your entire user base and why it is in your best interest. So I already gave this talk last week at RubyConf, and I think videos will be available soon. Plus, once our editor gets through his backlog, we'll be publishing an article that goes into even more detail. So the content will be there if you need it, if you find it interesting. So today I want to do like slightly a different thing, kind of like a director's cut, where I will include some things that I didn't include elsewhere, like, for example, hot takes. And you will notice that a slide is not present in the original talk by the presence of this clapperboard in the corner. And yeah, so with that said, let's go. I'll try to gloss over some of the theatrics of the main talk. So basically, the talk was based around the metaphor, around the Pentagon Pizza Index. Raise your hand if you're familiar with this concept. Quite a few people. So the point is, when like somebody bombs Iran, for example, late night pizza deliveries spike around the Pentagon, and they receive like a lot of orders. And then they can't serve you, a smaller customer that just wants a single slice. And it's not an abstract problem. We dealt with this a number of times. I dealt with this on a project called playbook.com, which is an awesome digital asset management tool for creatives. Their problem was that, well, they had a lot of problems with importing assets, to be honest. And especially when they signed large customers with a lot of assets that wanted to import files from their Google Drive, Dropbox, and OneDrive, and so on. And I think we did like 3 passes until we got this right, finally. So yeah. The next project was coveralls.io, which helps you to improve your test coverage. And my colleague worked on that project. He used a slightly different approach. And the problem was that they analyzed coverage reports on every single commit from every CI build from all of their customers. And some customers had a lot of commits, some only a few. And yeah, so many such cases. Also, some other colleagues had similar problems. And maybe you find it also relatable because if your app is multi-tenant and every SaaS app is multi-tenant, basically, because a tenant could be a user or an organization, so it could be B2B or B2C. And yeah, so in multi-tenant apps, the data is isolated, but resources usually are not. And when users contend for those resources, and some users are greedier than others, you probably have this problem. By the way, how many of you work on a SaaS application? Okay, everybody. All right. Then the talk goes on to explain how easy it is to miss this problem. Like, for example, this guy, Tony, the owner of that restaurant, he's snoring peacefully because he thinks everything works perfectly. And how it works is basically how your background processors work. You have workers, a single queue of jobs, and all workers are processing jobs from this queue. Now, imagine if a single client creates a lot of orders, then a small client comes in, we can serve that client. Why? Because of latency. And latency is like bad. We hate latency and we try to decrease it. But, so the way we try to decrease it is by adding more resources, more workers, or more likely, we're going to do some auto scaling. But there is a limit to how far you can auto scale, because you could have a limited number of database connections. Or even if you use a database connection pooler like PG Bouncer, you still could have another limited resource. But my point is, even before that, you will realize that throwing more money at the problem will just lead to diminishing returns because you just spend more money, but users are not appreciating it as much. And in other words, sometimes latency is unavoidable. Take, for example, like generating slop videos with AI models. It takes a lot of time. And so you can't get rid of latency in that case. But also sometimes it is avoidable, but it's not worth avoiding it. Because it is important to remember that our goal is to increase the revenue, not to decrease latency. And sometimes decreasing latency can lead to increasing of revenue if your project gets better for users, but it's not always the case. And another point is that implementing fairness could potentially help you spend less money on compute, but provide better service. And let's look at an example. So instead of adding more workers, what if we did this? We simply served a smaller customer in front of the large one. And notice that the total time to process this queue is exactly the same. But the quality of service got better because the smaller client is now happy and the larger client haven't even noticed. They already expected their jobs to take a lot of time. So the point is, if we have great latency, the greater latency, the greater the need to treat customers fairly. Now, we could measure fairness in a bunch of different ways. There are formulas in economics and networks, but we don't need all that. We have a first in, first out queue. We have high latency once in a while, and we have users that are greedier than others. Then we probably have this problem. Though in my case, users just straight up told us that they don't like how we treat them. So probably you already know that you have a problem. But anyway, let's try to think how can we implement fairness. Now, Again, let's look at the example. We have a shared resource, a pizza that is sliced into 7 slices, right? Yeah, 7 slices, and we have 3 customers with different appetites. Now, let's try to distribute this pizza equally and try to see some logic to it. So we give a slice to the mouse. The mouse is small, so it's already full, satisfied. Now we split the rest. We give a slice to the cat, a slice to the pig, a slice to the cat, and then the cat is satisfied, and we give the rest to the pig. Now, the pig, being a pig, probably would have liked to eat the whole pizza, but at the end of the day, the pig is happy because it already got more than everybody else. Now, this is like really super intuitive, right? There are only 2 steps. We have a shared resource. We split it into equal chunks. Then we round robin the chunks between the destitute, between the tenants that actually need this resource at this point in time. And every single approach that we're going to discuss will basically try to approximate these 2 steps. And the best way to approximate it is, or like the easiest way and most straightforward, is to have a queue per tenant and then pull at them at random. This way, everybody gets the same chance, right? The problem is, if we have a queue per tenant, we're going to have a lot of queues. And what's worse, those queues will be dynamic. So we have a dynamic number of queues. And the background processors that we are using today are just not built to handle this use case. Let's look at Sidekick, for example. So in case of the open source version, this is the request that every single worker, every single thread will make to Redis when it tries to pull a single job. This request basically does this. It pulls a job from the first non-empty queue. And if all of the queues are empty, then it would wait until there is one job to pull. And this is really good because it means that we won't hammer Redis with requests. However, if we have like tens of thousands of tenants sending all of them in a single request from every thread, doesn't sound like a good idea. Now, what about Sidekick Pro? It's actually even worse. Well, it is more reliable because it has this in-progress queues, so we don't lose a job when a worker suddenly dies. But due to that, it had to change the way it fetches jobs from Redis. So instead of a single request, now we have many requests, 1 per tenant. And if all of those queues are empty, it won't wait. It will keep trying to pull those queues. So it would only work if Sidekick supported dynamic queues, which is like we could change to which queues one worker is assigned in runtime. And we cannot. And it will never be supported because Sidekick it's basically complete. If you ever lurked in Sidekick issues on GitHub, you probably know what I'm talking about. So Mike Perham, the maintainer of Sidekick, is pretty adamant about some decisions, which is good, I think. That's why Sidekick is so stable. But the point is, it will never support it. The queues will always be static. And of course, you could try to change Sidekick, specifically how it pulls jobs from Redis. And some people tried doing this by changing the Fetcher API, but Fetcher API is not public for a reason, because everything, basically everything in Sidekick is built around how it interacts with Redis. And if you change that, everything could break, and it would break probably. That's why every single project that I saw that tried to change how Sidekick pulls jobs from Redis is now abandoned or basically just doesn't work. Now, what about solid queue? solid queue actually is more interesting. It does support dynamic queues, unlike any other, I think, background processor. Well, kind of support. So you could specify that a worker handles all of the queues that start with tenant underscore something, right? And it's not recommended because if you specify that it would have to make this request before pulling a job, but it is supported. And then once we pull all of the active tenant queues, we will make this request to every single queue. The problem is that solid queue would pull those queues in the exact order that the select distinct returned it to us. And yeah, because of that, it won't support fairness. However, it's actually pretty easy to fix, surprisingly easy. So if you just add a single line PR that shuffles those queues before polling them, it would kind of make it fair, but only in a limited sense, because everybody would be treated equally. But usually in a real system, we want to give some priority to paying users and have a little bit of more control. Basically, what we need is weighted queues, which Sidekick supports, by the way, and Solid Queue doesn't. However, while Sidekick will never support dynamic queues, I think Solid Queue could actually support weighted queues at some point, because the hard part is dynamic queues. And thanks to relational databases, we have that way to fetch these active tenants easily. And in fact, on MySQL, thanks to the loss index scan feature, that select distinct request would actually be fast. And so the problem is adding weighted queue support, but I don't think it's too far-fetched. So maybe at some point, Solid Queue would support multi-tenancy. Now, there's also good job. To be honest, I don't know why I included this in the comparison. I think I just needed a third background processor. The point is, I've never actually used good job, but it is interesting in a way because it uses a different mechanism to avoid lock contention. Instead of 4 update skip lock, it uses advisory locks, and also it relies on Postgres notifications. However, it takes a different approach. This is the official recommendation. Instead of naming your queues as subjects like mailers, SMS, and so on, they recommend calling your queues by latency, which means that you're going to try to maintain latency under that threshold, which means you're going to keep throwing more and more money and trying to scale forever, which I don't know, man. I think this approach doesn't sit right with me. I think it's more likely that you're going to just increase the 5 minutes to 10 minutes at some point and call it a day. But anyway, so this raises a question, what's going on? Is it really that hard to support multi-tenancy in a background processor? And as we saw, not really. Some come close, some are not, like Sidekick and Good Job. But overall, it is possible. However, we need to keep in mind that those are general purpose processors. They optimize for performance, and supporting multi-tenancy naturally would add overhead. And so, do we just build our own? No, we don't. Forget it. It's hard. So let's instead fix this problem with what we have, building on the existing infrastructure. And we're gonna explore 4 strategies: shuffle sharding, interruptible iteration, throttling, and per tenant queues. I know I just said that per tenant queues is not possible to implement with those background processors, but stick with me. I think there is a way to do this. But let's start with shuffle sharding. And to understand shuffle sharding, we need to first understand sharding. And sharding, I think we all understand, it's pretty easy. Instead of a single queue, we can make 3 queues, for example, and assign dedicated workers to each of those. and also come up with a way to route customers deterministically between those shards. For example, we could route customers whose names start from A to I to the first queue, from J to R to the second, from S to Z to the third. And so far, it works just as we would expect. All good. Now, a large customer comes in, and it doesn't block other shards. Great. However, it still blocks unfortunate customers who happen to share the same shard. And what's worse, though, is that now we have resource underutilization because we don't have any active customers right now whose name starts from S to Z. And so the third worker just sleeps. And this is normal sharding. In shuffle sharding, we could do this, for example. We could say, hey, so you could process your own queue, but when you have capacity, help out your fellow worker, your fellow chef on the left. We could say the same thing to the second chef and to the first. Now everybody helps out each other. Now notice that the chance of one user blocking another is exactly the same as in normal sharding, 1 to 3 in this case. But resource underutilization is not that much of a problem right now. But actually, like if you read the original article by AWS, which I think they coined this term shuffle sharding when they were implementing Amazon Route 53, they did in a slightly different way. Instead of shuffling shards between workers, they shuffled users between shards. So instead of routing a user to one random shard, they shuffled them, well, they assigned a couple of shards to a single user, or maybe 3, right? And then randomly chose one of those when enqueuing that user's work. But so it scales a little bit differently, but the end result is the same kind of, and which is now workers handle overlapping subsets of users instead of dedicated subsets of users. And this is the main feature what allows shuffle sharding to improve resource utilization. And by the way, this is what Mike Perham recommends from Sidekick. So this approach does not prevent queue hogging. Somebody could still block the queue for somebody else. And it's also not perfectly fair. It usually has full resource utilization unless you have like too many shards. But it scales very well, like amazingly well, in fact. It gets better the more users you have. So if you are at a scale, would be a really good approach for you. Now, the next strategy, it's called interruptible iteration. And so imagine that a customer creates an order for 3 slices. We could create 3 jobs with 1 slice each. But we could also create a single job with 3 slices. And so far, we haven't achieved much because well, a single job could be handled by a single worker at a time. So now other 2 workers are sleeping while the second one does the job. But it's not really a problem when we have enough workload for everybody. Benefit of this approach lies in the name interruptible, which means we could interrupt the processing of a single order. For example, we could process a single slice and then throw that job back into the queue, which would free capacity for other customers. And amazing, great. However, if a single customer now creates many such batches, fairness kind of goes out of the window. And this approach also does not prevent queue hogging. It's also not perfectly fair. It usually has full resource utilization, and it also scales pretty well. And it works well when we have workload that naturally comes in batches. And you may be familiar with this approach from, for example, Shopify job iteration gem, which was, by the way, invented or built by Roth, a former Martian, in 2019. And yeah, Sidekick iterable job is basically a port of that gem with less functionality for some reason. Like, for example, it misses like a core thing, in my opinion, the max job runtime parameter that limits how long can a single job processed at a time, because we need to interrupt the job to free capacity for other users. For some reason, iterable job just does not support this point. Now, we also have active job continuation, which was merged in Rails 8.1. It's kind of a different beast, but it could also be used for the same thing. It's more similar to Acidic Job Gem by Steven Marheim, if you know about it. Oh, all right. Now, let's go to the third strategy. The third strategy is called throttling, and this is the strategy that my colleague used for the project coveralls IO. And the way it works is basically we try to approximate fairness by punishing greedy users. We could notice that somebody is being greedy and then do something with them. But let's first try to understand, how do we notice when somebody is being greedy? Usually with a limiter, right? And my favorite one is the leaky bucket algorithm, which unsurprisingly emulates a leaky bucket. And it works very simply. When users try to enqueue more jobs, we fill the bucket with water, and that bucket has a hole at the bottom, so it leaks at a consistent rate, and it also has a limited capacity. So at some point, we could pour too much water into the bucket, and it starts overflowing. And when that happens, we know that something's off. For example, like the user is being greedy. Now, what I love about this approach is how incredibly efficient it is. Think about it. Like, we only need two numbers, literally just two values, to keep track of the state of each bucket. The timestamp of the last time we updated the bucket, and the water level at that timestamp. That's it. And every time we try to update bucket, we do just like kind of a few arithmetic operations. So its algorithmic complexity is also very nice, 0.1. So it's both storage efficient and computation efficient. It's a really nice tool to have in your belt. But anyway, so we noticed that a user is being greedy. Now we could start spilling the excess orders into a different queue, for example. And then we can assign different probabilities to those queues. And we would pull at them with, for example, from the fast queue, from the default queue, we could pull with 80% chance. And from the slow queue, we could pull with 20% chance. This is possible in Sidekick, thanks to weighted queues. In solid queue, I don't think it's possible, but still. Anyway, now the subsequent orders from the greedy customer would go to the slow queue, which would free workers' capacity for other users. There is one problem, though. If one user like has a bursty nature of the workload, like for example, tries to enqueue a million jobs at a single time instead of gradually enqueuing them over the month, then we could overpunish that user and throw a lot of jobs into the slow queue, which would be stuck there and would be processing at a slower pace. However, the good news is that once we get through, once we get through the fast queue, we could start processing the slow queue at a full rate. So what can we say about this approach? Like previous two, it actually does prevent queue hogging because everybody would get at least a little bit of work done before we start punishing that user. However, as we saw, it's not perfectly fair. but it has full resource utilization because we always process some stuff once. If we have jobs in queues, workers would be occupied. And it also scales, especially with leaky buckets. And it works great if the workload is pretty much well distributed over time. Like, for example, you don't create a million commits in a second and then don't do nothing. You usually do like commit an hour or something. Yeah, so that was throttling. And now let's take a step back and try to think, what do the previous three approaches have in common? And they scale, and also they all have edge cases. Now, if we want something universal, something that would be fair at all times, we need something more radical. For example, we could hire a manager. And a manager has a ledger. And what we would do, we would throw all of the orders that come in into that ledger instead of the main queue. And that manager would be asleep most of the time while his team does its work. Once in a while, he would wake up, see that the team is running out of work, and throw more jobs to main queue. And then sleep again. If that looks like a bottleneck, it kind of is a potential bottleneck. However, notice that it's also a single point of making decisions. And it could be like really smart, like a magician of fairness. It could, like, so the way it would be fair to users, it's completely up to that manager, but we could imagine that it would implement the approach that we discussed at the beginning of this talk, specifically having many per tenant queues and pulling at them at random. So he would kind of like maintain all of those queues in his mind. But let's look at the basic algorithm. And it's very simple. So all we need to do is to intercept jobs before they enter the main queue. Then we store those jobs in virtual queues per tenant. You could store them anywhere, for example, in Redis as well. And then we would need to keep track of tenants that currently have jobs in their queues. Then we need to run a periodic job, that manager job, basically. For example, once a minute. And what that manager job would do is that it would check the queue latency. And if the latency is already high, it would just go back to sleep and do nothing. But if it's not high, if it's below a threshold, it means that we have some capacity. And it would select jobs from active tenants according to your fairness policy. For example, you could give more weight to paying customers, or you could implement some cooldown. Like, it's totally up to you. And then it would promote them to the main queue. Now, notice that there are literally just two things that we require from a background processor to implement this algorithm, which is be able to intercept jobs before they enter the main queue. And I think every background processor supports this. In Sidekick, there are client middlewares. And the second thing is to be able to check the queue's latency. And in Sidekick, there's public API for that. So you could take this algorithm and implement it anywhere. And what can we say about this approach? Does it prevent hugging? Yes, it does. It's basically communism. I mean, if it worked. And it is also perfectly fair if you make it fair. Because if the manager is playing favorites, of course, it's not going to be fair. But it could be. It's totally up to you. And it also has full resource utilization, because for the background processor that you are using, basically nothing has changed. At the core, it's still one queue and many workers, and it scales very easily. I mean, you could scale the workers, but does the approach scale? Now, that's the question, because we have added a potential bottleneck. And so it is a central planner. That's why communism failed, central economy or something. Anyway, the problem is that kind of. So it depends on your workload. In my experience, it usually does scale because if your manager can enqueue more jobs, to enqueue jobs faster than they are processed, then you're good. Which means it works especially well if your workload is already heavy and is otherwise limited by other factors. For example, like AI workflows. Like I'm mostly talking about LLMs with a lot of small, slowish HTTP requests. Also, data imports, when we stream large binary files from one point to another. Every report generation, like heavy database requests, and then we compile PDFs, or media processing if you do something like FFmpeg or image magic, and yeah, and more. I'm sure you could come up with more examples of jobs that are long running and they occupy all of your workers and don't let others through. And if you pay attention, you may notice that some of these jobs are CPU bound, like media processing, but most of the time it would look like I/O, your Ruby processor. It would mostly wait on I/O. And so it's kind of tempting to think that we could just increase the concurrency by adding more threads, or maybe even using async like fibers. That would increase the concurrency so much so that we could forget about the problem, about the fairness problem. Fortunately, if you look at your system, like at this problem from the perspective of your whole application, of your whole system, you may realize that AI workflows could be limited by GPU capacity if you self-host the models, which a lot of companies already do. I mean, if you use APIs and just reselling tokens, then probably it's okay, it could work. But if not, then yeah, GPU capacity. With data imports, you may realize that you are limited by API quota that the cloud providers give to you, like Google Drive and OneDrive and so on. This was my case. And with heavy report generation, you may realize that you are straining database, because if you have unbounded concurrency and talking to a database, you could just strangle it, basically. So we can't just slap async on top and hope that it's going to fix the issue, because it would just move the bottleneck down the stack and won't fix the problem. Now, the key thing to understand here, and I think if you were to remember one thing from this talk, I think it's this, is that when a scarce resource is shared, fairness becomes a requirement. When we have a limited resource, we need to think about fairness. And today we saw 4 ways how we can achieve this: shuffle sharding, interruptible iteration, throttling, and per-tenant queues. We'll not go through all of them again, but if you looking for like a quick decision to make, I think you could start with the per-tenant queues, the last approach, because it would be fair in all cases, and it's pretty easy to implement, I think. And if you notice that it doesn't scale, then what you do is you look at the shape of your workload and try to decide on a more specialized strategy that would scale better. And yeah, also, this is the QR code, which you could scan to find the draft of the article, not the actual article, because we weren't able to publish it in time. But yeah, it contains all of the information and more if you want to look into this. But we'll soon publish it on our blog as well. And be sure to check out a few of other projects related to this problem, like MyJam, Sidekick Fairplay, that implements the last approach, then a jam of my colleague, Andrei Novikov, that implements throttling. It's called Sidekick Fair Tenant, and also a project from my principal, Vova, who has a specific sense of humor. So Yeah, I'm not going to pronounce it. It has a few of the other strategies which interest you, and it also does some benchmarking, which is pretty interesting. Yeah, with that said, I hope that knowing all of those strategies, you will never turn away a customer ever again. And yeah, thank you all for listening.
Alexia, I realized this was factually correct. So I'm probably you can consider me a manager at Evil Martians. And I woke up today at 6:30. I went to a call. I gave some tasks. Then I went back to sleep, just like in your slides. And then I woke up again, and repeat the cycle. Right. Okay. Any questions? Yes.
Well, you can come talk to me.
Yeah, we can do this during the break. But let's go. How are the energy levels? So we have a talk from Marco. We can make a short break now if you want, but we can go right in. Let's go right. Okay.
Short break.
Short break. Okay, 5-minute break. Let's do 5-minute break. Get some water. Hydrate. Hydration break. Right. Anybody has the Rexona banner? Okay. Now we know who watched World Cup and who didn't.
Dude, I got fired. I was like, oh, this company got money. That's not funny. It is like things was. That's the reason for it. We did all Thank you. What happens if what?
Sorry, that's happened. So
Right now, I'm doing like one person at a time.
okay, yeah,
Like not.
yeah. I would just. Give them like.
Oh yes, please.
We'll be trying to get into all my accounts still right now. Like yeah, but something like file description. That's such a good. I don't know if that's even possible.
And account of. I lost me off about that fast.
No, I'm not really that's It must be a very spot. I can't even remember the names, you know.
Yeah. Is that what you're doing? Okay, so basic, right? And I'm like. Let's say.
Yeah, we were. I was just saying like I won't go to Sentry and you're free.
Then if it's not, then this is my plug. I go to something that fails order, and then I type in the names. Let's do all that. And I go to contact.
Oh, yeah.
And then
That's what it is. A couple of years ago, I was sitting here there. Some years came out. Oh, it's just like, hey, what's up? What are y'all doing? And yeah, exactly. It's like, yeah. I wasn't able to. I didn't know there's something like what I by myself 95% of the time, right? But then it's like the one time where it's like you go out, it's the meetup. Yeah, you're like, can I just improve myself that once? It's like,
Over there.
and I just like swing down onto the back.
But again, I don't.
Probably going. It's like you like what's it called? Like a lot of it. Yeah, that's that's all you need. And you can see that I mean, that's how it's like it's a potential contribution of space.
I feel like
There's yeah, exactly.
Okay, everybody, let's do it. Let's do it. Question for you. Okay, what is similar between Marco's talk, which you haven't heard yet, but you know the name of it already, And Cameron, what's the same component? I don't, you know the answer? I don't. What is it? Prism. Yeah. So we have a Prism Day, right? No? Yeah, should maybe there's a way to also add fairness to Prism. Yeah. All right. Okay. So you guys all know Marco Roth. So without further, yeah, take it away.
Okay. Yeah, today I want to talk about a bit different about ERB rendering engines in general and the anatomy of them. If you haven't met, I'm Marco. I'm a full stack developer and open source contributor from Switzerland. And for the past few years, I've been focused on one corner of our ecosystem, which is the web views and the views in general of how we are rendering views in our apps today. And that obsession led me to somewhere I didn't quite expect a few months ago, which is deep inside ERB rendering engines. And today I want to take you on the same journey with me. So ERB was released in 1999, so it means it's 27 years old today. It's one of the oldest pieces of Ruby that most of us still use on a daily basis, and it renders your Rails views, it generates your mails, it templates your YAML configs, your scaffolds, your Docker files, pretty much anything. And you almost certainly used it this week or last week, but can you actually explain how it actually does that, all of that? What happens between you writing an ERB expression like this and the string coming out on the other end? If your mental model is more like, well, it interpolates the Ruby somehow, right? You are in the majority because it's not something you really look at and have to look into unless you are working on these internals or you have been encountering a really weird bug, but that's been super rare. So yeah, nobody really shows us this layer, but I want to kind of take a look inside today. And I mean this title quite literally because we want to look into it from an anatomy point of view. Anatomy is Greek, which means for a cutting up. And before it was science, it was kind of a verb, which means you learn how a body works by cutting one open and then going through and naming all the things you find. So that's the plan for this talk. We want to pick an ERB rendering engine. We will dissect it and see how some of these things work and how they compare. And here's kind of the single most important idea of this talk, which is that ERB is not a templating engine, but ERB is a Ruby code generator. So a ERB engine doesn't just interpolate the values into your templates. It takes a template file and writes a Ruby program out of it. And that Ruby program that runs is its output is the actual rendered templates, HTML, whatever you have. Which means you're getting a template in, it generates some Ruby source code that you can then evaluate, and that's the entire trick. Everything else, like the Rails integration, the escaping, the performance, and all of that is just a elaboration on the one move, which is what I just talked about. So every ERB engine is kind of a small compiler, and that's kind of the thesis of this talk. That's the anatomy of an ERB rendering is universal. Because of the last 27 years, there have been a few rendering engines, but they all share the same ideas and they share organs in the same shape. And it starts kind of in the late 90s with eRuby, which is spelled with a Y at the end, which was a C implementation of for the CGI era, and it released in 1999. And it wasn't just the program, it also was a specification for this eRuby language. Then in 1999 as well, Seki-san tried to write his own implementation of the spec in pure Ruby. And that's what became the eRuby or the ERB we have in the standard library today. And this shipped in 8.9, Ruby 8.9. You also notice that actually at this moment, from day one pretty much, we had multiple engines implementing this one contract, this one specification. And now after these 27 years, we have 6 engines, but they all still honor the same contract, which is getting in the templates, get a Ruby source out, you eval it, and they get render strict back. And this design survived because the contract is so simple So let's look at eRuby engine and look how this works. We use eRuby because it's the simplest or a simple complete engine that has all the features you need from an engine. And there's a couple hundred lines of codes, and it shows the anatomy really well, I think. So everything you'll find in this engine, you also find the other engines in some way or form. And this is the heart of eRuby. It's one regex, and this is not pseudocode. This is actually from the eRuby RB file. And the whole thing is actually a scanner, one input scan loop over all of it. So what we do is we match this opening eRuby tag, then optionally capture an indicator, which is the dash, the equal sign, or nothing. So one or two equal signs, a dash, a hash, a percent. And then we try to lazily capture everything up until to the closing tag. And then optionally at the end, also capture trailing white space for the different trim modes. This is kind of hard to look at, so it's kind of interesting to see how this all works. But this is pretty much the whole magic, the whole lecture. It doesn't really tokenize your templates. It string splits your template into pieces. So everything the regex matches is dynamic Ruby codes, and everything in between is considered static text. So the beautiful HTML structure you wrote in your views, eRuby never really sees or understands that. To eRuby, your template is pretty much just a alternating sequence between opaque static strings and Ruby snippets. So eRuby is one regex, it's one loop, it has one job, which is to render to a string as fast as possible. And which means eRuby engine with a string splitter as a regex, with a regex. And Cisco comes out on the other end, which is on the top you have the template or templates, and at the bottom you have the actual Ruby program that eRuby generates. So let's walk through it. First, we allocate a buffer. In this case, we call it _buff. Every piece of static text becomes an append with a frozen string literal. We want to freeze this because we want not to allocate a new string every time we want to render this template, so it can be reused. Your output of the name variable becomes this name in parentheses and call to string it. So you want to evaluate the expression first, stringify it, and then append it to the buffer. And then even the spaces inside this tag are preserved because eRuby doesn't want to touch anything it doesn't have to, so it stays performant. And the last thing is the last line is a post symbol. We want to call toString. You kind of return this value as the rendered output. And that's it. That's rendering. That's how your templates get compiled and rendered. There's not really an interpreter walking your file and doing this at request time. This compilation happens once when you first render it, and then it kind of stays cached. So yeah, rendering your view is in the end just a flat, boring, but extremely fast Ruby method that allocates, appends strings, and then returns the value, and that's it. If you have control flow, like if loops or whatever, they pretty much translate one-to-one into your templates or into your compiled outputs. And there's nothing special to that either. It's just a really incredibly elegant way of collapsing this problem to just taking whatever you put in the file gets put into your Ruby script, and that's kind of one-to-one. Yeah, that's kind of the thing here. This isn't just how eRuby works, that's how most of this engine works. This is just the example of how eRuby does it. So one thing that's worth noting is that in all these years, the job description of this engine never actually changed. It was more the tools around it. So in our case, like in Rails, the Action View framework, and in other engines, Hanami View, have been kind of working around this, and that's kind of where the whole innovation kept coming from. So in 27 years, nothing fundamentally changed. You had 6 engines, they had different buffer names, they have different escape defaults, they have extension mechanisms, but the anatomy itself, which is this scan, split, append, eval, kind of never changed. It didn't need to, it was right, and I want to be really clear about this. This talk is not about that eRuby is bad, or it's slow, or it's not doing the job. It's quite the opposite. I think eRuby is a masterclass in doing this one job very well. It's tiny enough so you can actually read over it over coffee. And it compiles a template to the fastest Ruby possible to do this job. which is a flat sequence of these frozen string appends, and it has been stable for over a decade at this point. And because it makes zero assumptions about what you are generating, it works for HTML, your mails, your YAMLs, anything you want to throw at it. So every design decision eRuby made is correct. And for the job, it was designed to do 999, which is turn the template into a string as fast as possible. There's one thing that eRuby structurally cannot do, and this is not because it's a bug, it's not because of a missing effort, it's more that we have this regex that just is the way it works to make it fast. So it cannot really tell about our structure, what we have in our view, especially if you are rendering HTML. It cannot reason about the closing tags, it cannot reason about that there are even HTML tags in our views. And nothing ever fails in stopping you from shipping a template like this. Browser just quietly fixes this if it can. And this can ship to production and might live there for years. The second thing is stuff like invalid nesting. Again, we don't really know that we have HTML elements, so we cannot really reason about that. And slightly worse in this case is that the browser wants to kind of fix this up for us. So if your JavaScript or your CSS relies on this, it cannot really, or it might even screw it up because it will automatically kind of insert an opening H1 tag 2, and then you have 2 elements instead of 1. And the last thing is stuff like invalid syntax. You have missing ends, you have missing or invalid Ruby. It will compile in these engines, but it will actually crash at runtime instead of what we want. This will crash in production on the first time you try to render it. And if you're using Rails, you might have seen a screen like this before, where you have pretty much no clue what's wrong, but you know there's a syntax error in the template, which doesn't quite help. To be fair, they have been improving these error screens. Rails 6 added this one, and also later versions added these highlights to show you where stuff is wrong. But there's still cases where you don't get any context, you could get any information, any error, any line numbers. You just get the template returned back to you that says something's wrong about this. And again, this is not because eRuby does its job bad, it's more the stuff that's around it. In this case, it's Action View that doesn't really know what to do with it. And we cannot really validate or assert something that we haven't really understood, right? So we cannot say there's an HTML error if you don't understand HTML. And this goes deeper than just error messages, because we also want to have agnostics, you want to have tooling, you want to do analysis, you want to do optimize things, and eventually do stuff like incremental rendering. And because the engine doesn't understand these things, we cannot improve our stuff around it. So we cannot really build a linter, we cannot really build a formatter, we cannot build a language server on top of this single regex that we just showed you earlier. That's kind of why I think the eRuby tooling story kind of lagged behind, that we never really got any tools for this kind of area. And semantic analysis is pretty much impossible too. And you have no idea of, is this output inside the HTML tag or is it not? That's simply things that an engine like eRuby cannot answer and aren't designed to answer. And yeah, if you want to do incremental rendering in the future, which means you want to just update the page where it changed, we need to be able to reason about what we are rendering and how we are rendering it. So this is one question that this sets up, which is kind of figured out by other ecosystems for a long time with reactive server rendering, which is, what if the engine itself parse the template instead of splitting it, right? And that's the design point I want to explore for the rest of this talk, using Herb engine as a concrete example, as I have been working to make this work. And again, the point isn't that I want to switch to Herb. The point is more to kind of show what changes if you kind of have this one thing that we change in the anatomy of an engine, and what this kind of allows us to do going forward. And I also want to be honest about where this engine came from, because it explains how everything else is designed. Because Herb wasn't born as a eRuby rendering engine, that wasn't the idea. I built the parser, the Herb parser for developer tooling first. And the engine kind of was a side effect out of that, because only when I started building the tools, I realized that I can take this stuff and also make it work for an engine. That's all we needed to make this work. So none of this was part of the original plan for Herb when I started working on this. So step one for understanding what we are trying to render is we want to have a real syntax tree, and we can do this by parsing our templates. And this is the same one-liner template we had before. But this time we see that the engine itself has a h1 element. It contains an open tag, it has text in it, it has a ERB expression, it has more text, and then it has a closing tag at the very bottom. It's lossless, which also means every byte of your source or of your template, including the white space, is kind of somewhere in this tree. With the line number and the column and the positions, everything is inside of it. And even the Ruby inside your ERB tags is being parsed by Prism, the Ruby parser Cameron talked about earlier, which has been shipping since Ruby 3.4. And also the interleaving is preserved. The engine knows that this h1, this name is inside your h1 element, and it knows about that. It's not inside the attribute, it's not inside the script tag, it knows it's inside this h1 element. And even if you have stuff like ERB ifs, conditionals, loops, it knows the nesting of those, so it can also reason about those. So the engine itself sees your template the way you see it when you look at it. And here's kind of the full new anatomy. And I want you to notice that this isn't really Herb specific, but the whole idea is that we parse, then we validate, then we can do some transformation if we want, and in the end we generate our generated Ruby codes or our generated compile template. And this is kind of what any structure-aware template compiler looks like. It's the same is true for Svelte, if you have heard of Svelte in the JavaScript ecosystem. Elixir's Heeks compiler has a very similar shape. And Herb is simply the first one that does this in this kind of new ecosystem in Ruby. But we also want to notice that we are doing incredibly a lot of more work, which is incredibly more expensive. And this must be kind of slower than the single regex pass that ERB gives us. We are walking a whole tree, we are tracking contexts, we are emitting these fine-grained tokens, so this must be slower, right? But here's the thing, after all this machinery, after this full parse, the validation, the visitors, the tokens, the optimization passes, the generated Ruby code that comes out of it is identical to eRuby's. Pretty much instruction for instruction, and these two examples here show them side by side. The only difference is that we're using ERB-H instead of eRuby-H to escape in this case. And that's not a coincidence. That's kind of the core design concern that I gave it. We want to have eRuby compatibility as a hard requirement. We want to use the same buffer variables, the same options, and the same escape semantics. Because the thing is, you pay this compilation step once at compile time, and later, when you try to render it, you are dealing with the same code, so it's as fast as the previous version. But compilation happens only once per template per boot of your app, so it can do this once and then cache it. And rendering happens millions of times, so spending the intelligence upfront and understanding what your engine is rendering is kind of worth the effort when you kind of later get the same or even more optimal output. And this is kind of how compiles in general work, and that's what they learned decades ago. But in this case, you just try to apply the same concept to ERB templates. So what does this cost us, and how does it work? What can we do with it? So first, you want to look at a ERB template. I compiled a single ERB template, a realistic partial, has 30 lines, conditionals, a loop, expressions, through both engines, thousands of times on my laptop. And maybe it's a bit hard to see here, but eRuby itself uses 21 microseconds to compile this partial, which is this one regex scan and this string concatenation. It's incredibly cheap. And Herb, in comparison, took 424 microseconds because it does a full parse, it does use Prism for every Ruby snippet, it does the validation, it does the visitor passes, it does the code generation. So it's about 20 times more expensive to do this operation. But that's the honest price of understanding, and that's what we're trying to do, and that's what we are trying to look at. And I'm putting this here on the slide to kind of show this, because you shouldn't be trusting a compiler talk that hides compile times. But now the math to make up for it, as I mentioned earlier, compilation happens once per template per process on first render in every environment, and it's not at boot time, it's whenever you try to render it the first time, right? So it kind of distributes over the lifespan of your process. So for an app with thousands of views, you are comparing 21 milliseconds in total for the kind of, or up to half a second in total distributed of your lifetime of your process. Meanwhile, the same app renders millions of templates every single day, and they should stay as fast as possible. So we are 20 times more expensive where you pass once to be smart where you kind of pass constantly. And that's not the trade-off, that's the whole job description of a compiler. But it kind of only holds true if actually the runtime, the render time stays as fast too. So let's compare that. So for runtime, actually rendering the partial, I compiled it with the same templates and then rendered it 200,000 times each. And we can see in this screenshot here, eRuby took 1.14 microseconds per render, which is over 870K renders per second for this single partial. And Herb in eRuby compatibility mode took 1.13 milliseconds, which is, funny enough, even slightly ahead in this benchmark. But this is parity. This is by construction. In the end, it's the same generated code, so we expect them to be as fast as possible. And even the benchmarking tool at the very bottom says it's false with an error, so it tells us this is exactly or about exactly the same code. So this structure that we kind of have, this parsing, the understanding that we have, costs us nothing at runtime once you compile the code. So the payoff kind of is verified and makes sense. And to remember here, this is while Herb is trying to imitate eRuby. It's trying to match its move one by one, which raises this other question that is like, what happens when you stop imitating and start using the knowledge we have to improve things? Think about why eRuby cannot optimize past these fast string appends. It's not a lack of cleverness, it's in a way a promise. eRuby renders any texts, mel templates, YAML, SQL, whatever you have. And that generality is its superpower. At the same time, it's also its ceiling because it cannot assume things about what you're doing in your templates. An engine that assumes nothing about what it renders must decide everything at runtime. And yeah, because that's where the information lives. The information is at runtime, and that's what we have to work with. So we cannot really improve upon what we already have. But Herb makes the opposite bet. It tries to narrow the domain, and every assumption we can kind of, every assumption we can gain and kind of move from runtime to compile time is preferable most of the time to kind of improve what we have. So we can assume we are dealing with HTML, and that gets us everything we already covered earlier, including the errors and stuff like that. But we can keep narrowing. We can say it's Rails. So the engine can see the render graph, it can understand your partial calls, it can understand how they nest with each other, and do other smart optimization, including inlining these partial calls, try to resolve them if they are nested, and other advanced features. One of the things you can also do as a side effect is showing you all the partials in your tree, kind of show you this view renders any of these other partials, and the other way around, we can show you where this partial is being called from, where it's reachable from, and kind of how this affects your structure. We also assume now it's action view, so it can be even more specific. And now the engine knows about your tag helpers. In fact, Herb ships a registry about 250 of these helpers, and it knows what HTML each of these helpers produce, and which arguments of these helpers become which HTML attributes. So for a growing set of the common ones, we can actually statically evaluate the entire call, which means if you have an example like this, we're using tag to the input to generate a input tag, and we have mostly, or in this case, all static contents, we can pretty much entirely make this static, which means if you compare this to how ActionView does it today, it's pretty much inlines your whole eRB tag as one thing into this safe expression append. which is a whole method dispatch, a hash construction. We have to escape all the attributes on every single time we are rendering this template, which will always produce the same static string at the end because we are passing the same arguments. But if we pass this through this advanced mode in Herb now, we can pretty much evaluate this to one single string upfront, which then makes this infinitely faster because there's no work anymore we have to do. We can just append the string as eRuby has been doing it for all the other strings in the template. So yeah, this is practically free, which there's no additional work to do anymore. But the honest trade-off here is we can no longer monkey patch tag the inputs at runtime. But to be fully honest, nobody should be doing that anyway, I hope. But yeah, the measured gain in some of the templates I've been testing this with, which shows that there's 3 to up to 150 times faster, depending on how helper heavy or like your view file is and how many of these helpers are supported by the static compilation. But these are all the results, but they already show there's some promising yields from this. But the thing is, none of this is possible with this general purpose engine that eRuby is, and it shouldn't have to be. We are trying to narrow the scope here to make Herb just the tool for HTML eRuby. And yeah, this is not because there's it's like a hard engineering effort or there's a lack of engineering effort in this area. It's simply because the information is on the scope. We don't have this context to improve upon what we already have. And this is also only possible because we are trying to be specific about the framework. We try to integrate the framework. We know the helpers. We know the lookup rules. We know these buffer variables and all of that. So that's the actual ambition. The ambition is, or the goal is not to build a slightly better Ruby code generator, but actually a fully fledged HTML templating engine that understands and can reason about HTML. To be a foundation for any framework that wants to build views with HTML and can build the entire view layer on top of that. So eRuby's genius was being framework agnostic. And the next step's power comes from being the opposite move. And the funny thing, in a way, is that none of these optimizations were even a goal. They were also side effects from building the structure we needed for trying to make reactivity work in this other project I'm working on called Reaction View. And I told you at the beginning that the engine itself was a side effect of the tooling, right? So it's like this whole chain of side effects that keep kind of paying off. And I think that's a thing that I want to also highlight, which if you have a good foundation where you try to build the tools on, it kind of keeps paying off in ways you didn't expect before. So that's about performance, about internals. Let's show some of the payoffs that aren't about speed at all. We have one, which is better diagnostics. We can see exactly where stuff is going wrong, where stuff is being compiled wrong, where you have invalid nesting, invalid HTML, invalid eRuby. We can see them in the browser. It will show exactly what's wrong about them. Payoff 2, which is once this compilation is this whole tree pipeline is based on the syntax tree, the compiler itself becomes a platform for additional tools. So in development, what we do is we have a debug visitor that walks the whole tree and adds or annotates the expressions with more, or stamps them with more information about where they came from, which line they came from, kind of like a source map to your source. So we have the file, line number, column, and so on, and that helps us build more advanced features. For example, we can see the outlines of your views and partials and their paths with the labels where they came from. We are being able to click on these labels to bring us to the editor to jump back and forth between our source and our rendered outputs. We can exactly show you which parts of your page are dynamic eRuby contents with these purple outlines versus which is just static text. And finally, we can also show you on hover which eRuby expression was used to generate the actual outputs as a in your browser, in your rendered output. And that's things that would be really hard to do if you have no knowledge about HTML and how to kind of inject additional attributes. And the final payoff is this development server I've been working on. the idea is you can kind of run herb def. And as we talked about, the engine now understands your ERB templates as a tree structure. And it turns out you can also diff these trees to kind of find differences between the before and the after. So by adding a new line to your proc file, you can run this def server locally. And what it gives you is this great experience where whenever you save a file, it parses the previous version and the next version of the templates, shifts the two syntax trees, and then pushes the minimal patch to the browser over a WebSocket. This is not a page reload. This is a single patch to kind of precisely update the location where this was changing. And the same applies for partials. If you have the same partial multiple times on a single page, it will update that partial in all of the instances that you have on this single page. And then if you introduce a syntax error or have some other kind of weird thing going on in your templates, whenever you save it, it will show you instantly what's wrong about it. It will show you this error page. And if you kind of fix the error or your agent fixes the error, it will automatically refresh the page and show you that everything is good again. And as I mentioned, this wouldn't be really possible with single regex splits to kind of reason about all these things. And it wouldn't know where to inject these attributes and so on. So that's the kind of idea. Which brings me to the bigger vision, the reason I started digging into ERB engines in the first place, which is Reaction View, this initiative to try to build Action View itself reactive, similar to how Phoenix Live View or other tools like it work. And I've been asking this question for some while now, which is what becomes possible when the engine actually understands what it renders. So with Herb as foundation, we can try to build this feature or this future. And we can look at what the engine knows. We know you are rendering this part of Ruby instead of this elements. So we have this mapping between the elements and the source, how state flows for your templates. And this is the foundation we need for this fine-grained reactivity and how to make this work. It's how Phoenix does its magic, how the Heeks templates it uses are compiled with structural awareness and this change tracking right built in. It's how Svelte works, it's how Solid works, it's how all of these tools work. You keep your ERB, you keep writing server-rendered HTML, you keep the state on the server side, you have a single source of truth, and when your page needs more interactivity, you opt that single page in for more advanced features, per template, per route, whenever you need it gradually. And instead of rewriting your whole frontend into a JavaScript framework because 5% of your app need to be reactive or have more interactivity. The good news is that earlier in April at RubyKaigi this year, I shipped a new version of Herb 0.10, which ships all of these primitives we need to make this work, the foundation for reactivity. And that's what we are working on next to kind of try to build this reactivity in Reaction View. There's one more step on this road, which is Rails World in September. I'm going to be talking about Herb in Rails 8.2. Herb is on track to become the default engine for HTML ERB templates, and it keeps ERB around for all the non-HTML ERB templates. And that's kind of the idea to bring this into Rails, try to make this and how to be worth the effort to have this in a framework like Rails. I'm looking forward to share more about this in September when we get to merging this into Rails. So let's zoom back and compare what we have. In eRuby, we have a regex scan, straight to code generation, fastest possible path to a string. But we have zero understanding of what we are rendering, which is by design. And for this longest time, this was exactly the right call to do. In Herb, we parse a lossless syntax tree, we validate, we transform, and then generate the codes. The same string at the same runtime speeds, sometimes a faster one depending on the templates, with the difference that the engine understood every byte it emitted, and that whole engineering or understanding is kind of adding up. We get diagnostics, security, tooling, dev tools, optimizations, and eventually this reactivity I just talked about. And all of that kind of falls out of this one decision. to change the anatomy that we are parsing instead of string splitting. But for 27 years, every ERB engine shared the same anatomy. And this is just the first engine that has a different anatomy, and it still speaks the old contract fluently. And that's the whole trick. We want to just have a revolution in the anatomy without having to have a revolution in your code base. So not a better string concatenator, but a different answer to what a template agent is. And I think we want to have a compiler for a language that deserves one. ERB has been quietly compiling your templates for 27 years, and ERB's design was never magic. It was always a compiler, even if it was a beautiful, simple one. But the single regex pretty much carried Ruby's entire web story in a single regex. For the next 27 years, I think it belongs to engines that understand what they are compiling, at least in the context of web views. The contract stays, template in, string out, same speeds. What changes is everything the engine knows on the way. The Ruby community has built incredible tooling for the language itself, and I want to bring the same care to the view layer and keep Ruby and Rails as attractive as possible for the next person who finds them. Finally, some acknowledgements. Joel Hawksley at GitHub has been adopting Herb at GitHub scale, which is really exciting to see. So I want to give a big thanks for him pushing this at GitHub and also reporting and fixing a lot of bugs while he was at it. I want to give a big thanks to everybody who used Herb or reported issues, to people contributing to the repo itself, and finally to my GitHub sponsors that have been supporting me on this journey. So please try the tools, report issues, give feedback if you have any, start a repo on GitHub, and check out the docs. That's what I have for today. Thank you so much.
Thank you, Marco. I'll go first. First of all, the reason Marco was so nervous today is because Jeremy Evans, the author of eRuby, is here. You have guessed, right? So thank you, Jeremy, for 27 years. Yeah, it's a great bridge, I think, for very nervous. Okay, I'm kidding. Okay, I have another one, another comment. If you guys are, doing a lot of agentic development in the view layer and for the using Rails frontend, using Herb as a linter, and building custom rules and building what we call gates right now is great. It's just a great tool for your, agent generated views so that you can prevent it. Herb can prevent a lot of degradations that are common for your project. So I would recommend that. And yeah, just adopt it. If GitHub can run it, probably your project also can run it. Yeah. More questions?
Thank you for the talk. And I was wondering if you could give a little story about the name Herb and why you might have chosen it. If you're the one who named it. Yeah, I don't know if you're the one who named it, sorry, but any backstory?
Yeah, I was one naming it, and it's pretty much H as an HTML, ERB. That's the whole story.
Wait. The right pronunciation is Herbie. Yeah, Herbie. Yeah, that's the right one. I'm kidding.
But I always pronounce it with an H to be sure we are not confusing it with ERB, because I have been noticing people also pronounce ERB as herb. And if you have the American pronunciation, it's kind of the same. So I've been trying to make sure that I pronounce the H.
Yeah, I'll just okay, cool. Folks, we'll have some time after this, but first we'll have a little piece from Sentry, and then after this, let's do this. Right after this, let's do our round of intros. So let's start kind of getting ready here. Yeah, go ahead.
Good evening, everyone. Thank you all for taking the time and coming here. Once again, big shout out to all of our presenters that presented today. It was good to learn what's happening in the world, other than AI, of course. My name is Arjun. I have been at Sentry coming up on 4 months. So whatever I tell you, take it with a grain of salt. And if you do or don't see it as a true source, please blame Claude. Do not blame me. Do not blame my manager, and do not blame Sentry. Just kidding. As some of you know, some of you don't know, what is Sentry? Sentry essentially is an application monitoring platform that sits with you and is your assistant throughout your journey. Anytime, anywhere, someone clicks on your code, an action that's performed, anything that happens along those lines. Now, how exactly does that help? What exactly does that do for you? As developers, and also as a former developer, when something breaks, it's very annoying. It's very painful, especially at night when you're sleeping and you get a page from your manager. Hey, you did a commit, you didn't test, and you still deployed it. Can you please figure it the heck out? Then you're like, well, I don't know what I did. I don't know where the commit was pushed, and I don't know where exactly my code broke. Well, that's where Sentry comes into place. Sentry essentially helps you figure out what line your code broke, where it broke, when it broke, what's the reason, how are all the consequences, how exactly are your customers responding, what exactly is going on. How exactly does that play in your daily life, right? Let's just say, for example, you have a front-end application and then a back-end application. They're connected with each other in some way, shape, or form. Now you're trying to figure out, like, okay, I pressed checkout, but something failed. Well, as a magician, you normally know how the magic is performing. So the magician here is Sentry. The magician is going to figure out, hey, this is where things went wrong. This is what's happening, and this is what needs to be done. Now, as developers, we love that. Why? Because it's telling you the exact place and it's showing you throughout the process. Sentry works in many ways. A few of its products are errors, logs, traces, and again, we live in a world of AI. So how exactly does AI come into the place? Now, we have our seer agent, which essentially is its helper, its guide, and it's going to see every time an action is performed, it's going to take its context and help you build a story. Now, that story is essentially going to use to triage whatever error that may have happened. It could be in your front end, it could be in your back end, or anything along those lines. Again, I don't want to bore you guys more with the Sentry spiel, but I am in the back. I'm happy to talk more. I'm happy to geek out or whatever else. But again, just a quick little spiel of what Sentry is, what it does, and how essentially it can help all of us. Thank you.
Thanks, Arjun. Folks, question, who used Sentry? Who didn't use Sentry? That's a better question. Literally, I think it's really rare to find a Ruby engineer who didn't use Sentry. Yeah, and but who tried Seer? Okay. Who allowed Seer to actually fix something for you? Yeah, that's a big higher trust, right? So this is where we can obviously chat more about it, because usually you get a free, I think, a couple months of Seer at some point, and yeah.
If at any point, if you guys are a self-serve or an enterprise account, there is something that you guys can always do is ask Seer. If you guys want to learn more about it, just Google Ask Seer or just go on Sentry Docs and ask Seer as well. It's going to pretty much add more context to your stories or context to any sort of errors that you're trying to understand or want to get more understanding about.
That's pretty cool. Right. Thanks again. Folks, let's do that. So we're doing that. Let's do that. Let's do it now. Let's do 60-second intros. So, and we'll do the full round. Then we'll go into just talking to each other, etc. So this will wrap up the official part. I will start, but I want people to kind of line here, right? Let's do that. Come on. Yeah. All right. It's very simple. So my name is Irina. I'm relatively new to San Francisco. I only moved less than 3 years back. Immediately started running this meetup, and it's the biggest joy. I just adopted a cat recently, and I run Evil Martians. And yeah, please come work with us if you have any problems like background jobs or anything like that. And the next one is Julian.
Thanks, Irina. All right, so my name is Julian. I am a big fan of Ruby, big fan of Rails. Obviously, I wouldn't be here tonight otherwise. Big fan of the cloud. Also worked extensively with generative AI, RAG, knowledge bases, and so on over the last, and agents as well over the last couple of years. I'm currently actually interviewing for my next role. So if you do have any tips or currently hiring, happy to discuss more. Anything that would sort of assemble all of these 3 or more interests of mine. Yeah, that's about it. Thank you.
Hi, my name is Sahil. I came to the last Ruby event. I thought it was pretty cool to just be around a developer community. I've only just recently started like exploring the different frameworks and web frameworks. I picked up TypeScript and Ruby to like kind of understand the different languages and how they work for web development and web application development. I just recently got picked up by Microsoft as a contract, so that's pretty cool. Although I think most of the work is now just learning how to cut through the sludge of permissions and everything rather than actually learn how to code. So not sure if I'm doing much in development, but it's pretty cool. So yeah.
Hello, I'm John. I'm Bay Area native. Been doing Ruby for like 15 years, contracting for the last like 8. If you need any contract Ruby work, let me know. My other interest is meditation. I have a website, johnkap.com, jonkap.com, if you're interested. Thanks.
Hello, I am Brad Gessler. I am co-founder of gbrain.io, just wrapped YC Spring. So I'm working on that. I think the more interesting thing though is I'm trying to build that out with this thing called LoopYard, which is this open source harness. And I can build this like, the goal is that I can build software for my phone exclusively. I don't want to have to screw around with Claude code and all that fun stuff. I just want to be able to like click a button, spin up an environment, access it from my phone, build it from my phone, like do everything from my phone. And that's mostly driven by the fact that I have 3 kids and I just like have so much crap going on that I need to just constantly like be kicking AI agents and proving their changes on real environments.
Okay, good. I'm also not too tall anymore. Thank you, Irina. My name's Andre Arco. I've been doing Ruby stuff since the 2004 or so, and I guess historically I'm most famous for working on Bundler, and nowadays I'm working on RV, whose website is rv.dev, a Ruby version manager and gem tool manager, and for working on gem.coop, which is a gem server for letting anyone publish gems for other people to use. Yeah. That's it.
I'm Dave Sick. I've been developing in Ruby for about, 12 years. I used to do product management before that and kind of wanted to get in the weeds, and I've been enjoying that ever since. I work for a company up in Truckee called New Leaders, but live down in North Bay, and really enjoy coming in here to learn from all you guys. And right now I'm re-architecting a scheduling system that's kind of growing exponentially and working with like Elasticsearch and GoodJob. And it was really interesting to hear kind of the different queue management techniques because I'm dealing with all that. So that's what I've been working on.
Hello, my name is Brian. I see on the screen, I'm not too tall. I got thrown into Rails for 3 years when I was working at a company called Afterpay. I the beginning, it was rough, but I learned to enjoy it. So right now, looking for a job. So in the perfect world, I would like to get back into the Ruby Rails space. So I've been using my free time to actually learn Ruby, not just Rails, because they said I was already do it. And I know we talk a lot about AI here. So one of the things I'm also exploring is how to get models running on my personal hardware, so I don't have to keep paying these subscriptions to Anthropic and OpenAI. So playing with that. Then I learned today from, I think it's Alex, that communism is fair, but doesn't scale.
Hi, everyone. I'm Cosmo Martinez, and I work at the University of California, Berkeley. And I support our administrative applications, which are mostly in Ruby on Rails. And my job is to keep everything safe and dry with this upcoming AI storm.
Hello, my name is Braulio Martinez. I'm visiting from Uruguay. I came for RubyConf in Vegas. I'm the founder of Cedar. We help startups grow their teams and build MVPs. I've been doing Ruby since 2010, I think. I maintain a bunch of gems around passkeys and that kind of thing. And yeah, I gave some talks about that topic. So if you want to talk passkeys, I think I'm your guy.
Hi, I'm Matt. I've been doing development with Ruby and Ruby on Rails for 14 years now. I currently work at Apple. That may have come up earlier in the evening. Thanks, Irina. Outside of that, though, I like to play golf, and I'm working on giving your agents persistent learning, memory, and recall. And I'd love to talk to you about making machines think better. So.
Hello, everyone. I'm Jeremy Evans. I'm author or maintainer of SQL, Rhoda, Rodoth, and eRuby. I'm really excited about Herb and looking forward to seeing what happens from them. And certainly, my company, Ruby Cloud, is looking forward to using Herb in production as soon as the bugs we filed were fixed. We are hiring, so if you are interested, we do a lot of interesting system work for open source alternative, AWS. So if you're interested, please talk to me. Thank you.
Hello, I'm Steven Anchetta. I'm an engineering team lead at a legal support company in Sacramento, California. I'm from the same city as that guy, Jeremy Evans. And I'm also coordinating the volunteer efforts for San Francisco Ruby conference. So if you're in the area from November 10 through 12 and you want to talk about volunteering, please speak to me.
Hi, I'm Todd. I've been working in Ruby on Rails for about a dozen years. I am looking for work, so if you need some help, please let me know. In my free time, I've been doing some open source work, so please ask me about that. Yesterday in my free time, I assembled a desk with my 5-year-old granddaughter, and that was a pretty cool project. She, however, tells me not to get a job, so we've got a little conflict there. Thanks.
Hi, my name is Alexi. I'm an engineer at the Electronic Frontier Foundation, which is a nonprofit headquartered here in San Francisco that supports user developer rights, privacy, legislation, things of that nature. In my day job, we maintain several Ruby on Rails applications. We have some cool examples. We have like a map of surveillance technologies in use, so by local up to state governments and things like that. We have a map of technology along the border that's used to track you and things like that, all Rails and open source software. And as you know, it's getting very challenging to write software and maintain and host it without the help of AI or respecting user privacy. So if any of that interests you, come find me and talk to me.
I'm Scott. I've been working with Ruby and Rails for 20 years now. And kind of on a little fun employment sabbatical for a while, and doing a lot of outdoors skiing, hiking type stuff. And with tech stuff, just kind of playing around with AI and, you know, making the robots do things. It's pretty fun. So yeah, I guess that's about it.
Hey guys, I'm Atan. I'm a current second year at UC Berkeley. So thanks for keeping everything working. I've been writing Ruby for a little over 2 months now. I'm a current intern at UbiCloud. I want to reiterate, we are the open source alternative to AWS. So please, if you love open source, which I believe we all do. I've been doing a lot of the networking stuff, hardware adjacent stuff at UbiCloud, reinventing the wheel, mostly writing stream multiplexing protocols. And thank you guys for having this. I was at the previous one, and these meetups are so fun.
Hey, what's up? My name is Valerie, and I'm working on a project called Prompta. And I'm looking for it's a question for audience, by the way. Raise your hands if your project like related with the AI generative, like it's generating videos or generating voice. Could you please raise your hands if you're working on this kind of project? All right, I see the guy. All right, I'll talk with him. All right, we'll talk. All right, is that everything? Thank you.
Hey, I'm Ken. Yeah, since Rails since 1.1. Do you have an office? Not many people do these days, but if you have an office and you have an extra desk, and you wouldn't mind me showing up at your office every day, I would love to come sit at your empty desk. So let me know. Thank you.
Hi, my name is Aurelie. I am a senior software engineer at Zendesk. I work for like anything that is related to globalizing, internationalizing products at Zendesk. Also, I will be part of the organizing team for the SF Ruby Startup Conference. Speaking of which, you still have 5 days and a little bit less than 4 hours to submit a talk. So I invite you to do that. If you need the link or whatever, it's on Slack.
Hello, my name is Ben. I'm the head of engineering at Bucket Robotics and the CFO of the San Francisco Triathlon Club. So if anyone bikes or runs and wants to come to track on Tuesday, please let me know. That part's a lot of fun. At Bucket, we take customer CAD data and we make synthetic data sets with it to train vision models that can perform quality tasks without ever having seen the part in real life. So if you like how it's made or manufacturing stuff, also come talk to me.
Hi, my name is Spartan. I kind of frequent these meetings. I'm an immigrant to the Bay Area since 2014. Usually working on backend systems, mostly Ruby. It's the first time. Currently working on any Roth as a software engineer. Collaborate on multiple open source projects. Nowadays, not too much, but I have a lot of things to do. On my free time, I usually just hang around the network, on the social networks, nagging you about be kind to each other, be anti-racist, use your public libraries, and you will find me easily on mostly everywhere as a Spartan, and to be here.
Hi, my name is Miles Georgie. I love hacking on all kinds of Ruby stuff. So if you want to hack on stuff together, you can find me on the SF Ruby Slack or however. Recently, I built a video game using only Ruby. It's a multiplayer 2-dimensional space hockey game. front end uses a game engine called Taylor, and the back end I intentionally made heavy use of Raptors just to learn stuff about Raptors the hard way. I'm calling the video game Trianco just because it sounds like triangle and the .com was available. I was told we can't screen share, so I'm going to try to cheat here. I don't know if that works. But yeah, you can play it online in your browser, or there's also a Linux binary. Thank you.
Hey, I'm Andrew, and I work on Buttercut, which is an open source video editing agent written in Ruby. So if you're interested in video, talk to me. We've got over 500 stars, and I also just rolled out like a fancier pro version about a month ago. I also just started working at Cisco a few weeks ago, so I'm working on agents there. So if you work at Cisco, say hi.
Hello guys, my name is Kenneth. I work for UC Davis and building some educational systems. For Ruby on Rails, I've been building my first Ruby like 16 years ago, just hosting a project for NonPerfect with some students, and now those students became senior engineers and senior data scientists, so it made me feel really old. So, and I love Ruby. It's super easy to maintain. Like after the system running for 16 years, still running strong. So yeah, I appreciate it, guys.
Hey, I'm Adam. In 2015, I built a Stripe Connect platform that wrote Stripe checkout code for non-technical people who wanted to put subscription buttons on their website. But back in the day when Stripe checkout would like dim the screen and it would pop up on the screen. And I turned it into a membership plugin, and I've been running that. It's a B2B SaaS. I've been kind of digital nomading, mostly in Latin America, and running this for like 10 years. It was purchased by Square, and it's in a app store that's being sunsetted. So I'm looking for technical product manager roles. And I want to talk about digital nomading and living in Latin America and working from a beach on Starlink. I can talk about that too. All right. Thank you.
Hi, everyone. Good evening. My name is Jono. A little bit about me. I like to run, climb, play basketball, bike, read, write, play chess. I don't know. Those are some of my hobbies. I'm actually quite new to the tech space. I actually just graduated from college about 2 months ago from UC Berkeley. So go Bears, go Bears. And yeah, I basically started my first role about a month ago with a company called Dosu. We're essentially centered on knowledge infrastructure. So if you are an engineering lead who, you know, is dealing with issues related to like fragmented knowledge across your sources and that dreaded token expenditure, as we all know, I got you. Would love to talk with you. But yeah, thanks for organizing this. Appreciate it.
Hi, my name is Aaron. I'm a software engineer. I'm more in the React side, but I came because somebody recommended me this event. So I'm just for hanging out.
Hello, I'm Raymond. I'm a full stack developer. I've been working on Ruby on Rails for 10 years, I think. I'm coming from Sacramento, so it's nice out here compared to there right now. So that's been nice today. It was 100 degrees yesterday. A fun thing that I'm looking forward to is that I've been working in the same company for around 7 years, and I've never met my coworkers, but next month I'm visiting them in Pittsburgh, Pennsylvania. So I'm really excited. If anyone knows anything about Pittsburgh, Pennsylvania, let me know so I know what to do. But yeah.
Hi, everybody. My name is Chris. I realize there's a lot of people here who went to Berkeley. My dad went to Berkeley. I didn't actually end up going there. It was a little too close to home. I went to UCLA, the other Bear college. I've been working with Ruby on Rails for probably too many years at this point. I still remember the Ruby on Rails book that I found at UCLA in the library and looking through it and thinking how much better this is than the PHP Zen framework that I was writing apps in before. So that was really fun, trip down memory lane. I work at a company called Gusto. Our tagline says we do benefits, payroll, and so much more. I'm not really sure what the so much more is about, but I noticed there's a lot of people saying that they're looking for jobs and whatnot. Gusto, we are hiring, so if you're interested in any of those three things, you can come talk to me. I recently released a gem called IETN message format. I think I'm kind of becoming the internationalization guy around here. It is one of my passions, so maybe we can talk later. Hopefully I gave a talk about it at RubyConf. Hopefully that recording will be out soon, and I implore you all to watch it and try out my gem. Yeah, thank you.
Hi, I'm Andy. I come here sometimes. I almost forgot that I went to Berkeley until you guys mentioned it. So yes, a lifetime ago. Rails, I used Rails in my first real engineering job 5 years ago. And you can boo me if you want. I mostly develop with JavaScript, but I'm deeply interviewing using Rails again. So I went to the fun of installing RubyMine on Windows and everything, yes, on Windows. It's fun and it's buggy, and what do I do now? I've been teaching elementary school robotics and programming. It's fun over the summer occasionally. I wasn't here because waking up at 5 a.m. in the morning does not go well with this during the school year. I also am a musician and I perform Balinese gamelan, many things, but yeah, if you want to talk, yeah, cool.
Hello, I'm Ronan. I've been coming to this meetup like for a long time now, since the very beginning almost. I've been working on the application that is meant to be a platform between marinas and boat owners called YARV. Like to manage your marina and to manage your boat and everything in the between. Aside of that, I'm putting solar on my van, so if anybody has tips for that, I'll take it.
Hi everyone, Jonathan. I guess like I started my, devish career. I'm not like a dev. Like I worked so many different types of jobs, like IT manager at NerdWallet. Worked at GCP at Google Cloud as like a big data AI specialist, and I guess last corporate job I was at AWS. So shout out to UB Cloud. I guess I'll talk to you guys after. yeah. I guess like more recently I've been more going into like open source and of course the AI stuff. I actually don't like it. Like begrudgingly, I use it. It's like last year, so like it's just like you just can't ignore it, and especially in the city. So, yeah. So if you're looking for a non-AI Andy, you can speak to me after, I guess. I guess more recently, trying to found a company. I guess like I didn't have a great time at AWS, to be honest. So I'm doing that. I just found a co-founder a few days ago, so that's pretty exciting because I don't know. I've been trying to find people that are like reliable, actually want to build a startup. I won a hackathon with one of the prizes, the pre-accelerator, and like the two people I worked with, like they weren't interested. So I don't know. It's been difficult for me just finding people to collaborate with, and like finally it's been like meshing, like going well. So hopefully it'll continue on this path. So. Yeah, if you're in the same boat, keep on going because even if you burn out or whatever, like as long as you keep on going after you pick yourself up, there's always like I don't know, the sun always sets, but it always comes up after. So yeah.
Hello, so I'm Ganesh. I'm a developer for a long time. And I've been working with open source for a very long time. Initial days of Linux, so that puts me into 90s. In that, I got introduced to Ruby and Rails around 2013 in one of the applications I was building at work. I worked with a lot of startups. I chose the Ruby on Rails, and from there I got introduced to the community. And I got more pulled into this. I mean, I have done a lot of, I'm a polyglot. I'm doing C, doing Ruby, Elixir, JavaScript, Java, and whatever is the solution or problem I'm solving. So I really got attracted to this community because, and I'm from the South Bay. All the time I come here in San Francisco for this meetup because this is the nearest place I find it. But I know some people come from Sacramento to here too. I work with Ruby still, but my more focus is on here for last many years. So, but it's I see both communities together, and I meet. So I was in the Ruby conference last year, and I could meet Dave Thomas, the people who kind of pulled me into this. So I'm glad to be here. Whenever I get a chance, I try to be here.
Yeah, I think there's a reason why Elixir engineers will always be welcome at all the Ruby events because of José Valim, whom we think he's a Ruby guy, right? He contributed to Ruby enough, I think, before building Elixir. All right, yeah, right, yeah. Oh yeah, okay. This concludes it. I want to say just a few more words. So everybody who's looking for a job, if you will apply at our sfruby.com/jobs, again, all of those companies are desperately looking for engineers, for real, seriously. And including, I will mention Persona because those guys just sent me an email yesterday and asked, how can we make people apply, please? Yeah, and Persona, you guys remember them, right? They hosted us also, and it's a great team, great product. And again, UB Cloud and Gusto and like all of them are really. So I just want to convince you, some of you who are looking for jobs, to just go and apply. And if you don't have the best experience, can you find me on SFRuby Slack and send me a DM with your feedback? Because I'm actually looking to build a two-sided matching platform for us after the conference. But the thing about this two-sided matching platform is it should be based on people's experiences and how it's not really about building, yet another SaaS. It's about figuring out what's broken and what can be improved. And if you can share your feedback, looking for a job as a Ruby developer in San Francisco now, I'd be very grateful. And finally, again, just the final words about our conference. This year, we're hosted by SF Jazz. It's going to be beautiful. It's going to be a very nice venue. And we'll have the main stage, and we'll have a smaller second venue that we use for networking. And what we're going to do is we're asking you for an intro when you're buying the ticket. So please fill it out with details. And then we'll try to match you with the groups. For example, if you like working at early stage, you consider yourself a founding engineer at early stage, you will be matched with founders of early stage startups. And if you like working on performance or at scale, then you'll be matched in groups with those companies like Gusto and Persona, and they will have them present their team and talk about their team, so you can hopefully both sides can get a sense of what it's like to be in the company, to work in the company, and then what they're looking for, and etc. You can get. My goal is to make sure that everybody gets value from this company, right? So even if you're not looking for a job right now, you having friends in all of those companies will make you feel a lot more secure for your future job search, right? And maybe you'll decide, hey, I really want to join this startup, even if you're not looking right now. So this all happens, and maybe you'll find co-founders, etc. So we'll have special networking for founders. This is going to be probably with Garret.js and some other way. So, this is where my head is right now, how to not just let you network in a hallway track, but also actually bring you together in smaller groups and kind of force this networking like we do it here, which I think I hope you enjoy it. But if you don't, you have to do it anyways, So yeah, let's talk. Please, please talk to each other. Please talk to me. It's a pleasure. And then after this, we'll probably continue in a bar as usual. And finally, if you're not on Slack, find the Slack link on sfruby.com. Join Slack. All the announcements are there. And yeah, let's chat. Let's bring ideas and let's talk. Thank you all. Thank you.